Okay, so for problem 9.2-2, a steel propane tank for a barbecue grill has a 12-inch inside diameter and a wall thickness of 1/8 inch. The tank is pressurized to 180 psi. Determine the axial stress and the hoop stress in the cylindrical body of the tank. Determine the tensile force per inch length of the weld between the upper and lower section of the tank, and determine the absolute maximum shear stress in the cylindrical portion of the tank. Okay, so yeah, section 9.2 chapter 9 in general are pretty easy. It's just the axial and the hoop stress in a cylindrical and a spherical shaft. Then you're basically good to go, right? There's a lot of it is just a combination of this with Mohr circle, or chapter 9 with 5, and chapter 9 with 5, maybe with 4, to add a torsion in there. But something, similar to along the line, right? And that's what you should be expecting from this section. Okay, so easy stuff. We can just start with the two equation that they gave us. We're going to use it, which is PR, right, over 2T. That is the axial direction, right? This is this direction, and PR over T, that is the hoop, right, which is, or perpendicular, right, or like that. Okay. So it's pretty easy. We have P, we have the thickness, which is T, and we have the diameter. So the diameter is 12 inch, which means it's 6 inch as R, right, as the radius. Now remember to divide it by 2. Yeah. Okay, so we can plug it in with P, 180 psi. I think the next important thing to care about is the units, but psi, everything is in terms of inches. It's good, pretty straightforward. What's T? T is 1/8. Okay, so you plug, and then so H is just equals to this times 2, right? So what does this give you? Let's see, you plug everything into a calculator, is 4,320 psi, right, or 4.32 ksi. It doesn't matter, just different units. Times 2 is 4.64 ksi, or 8,640 psi. Okay, and this is part A. So let's do part B over here. It says determine the tensile force per inch length of the weld between the upper and lower section of the tank. Okay. So basically we're gonna use the let's see. Yeah, we're gonna use the A because it's going, the weld is over here, right? This is the upper section, this is the lower section, and sorry. Yeah, I guess, one is going this way, so this is going this way. Yeah, the reaction, or the internal. So they're going this way, and the forces that are going this way in a cylindrical coordinate or cylindrical section or segment of the object, that is this, right? And the length, and the thickness of the wall is 1/8, right? So basically it's just that divided by 1/8, the thickness, and that is basically, times 1/8, my bad, times 1/8, right, which is force per length. Okay, so if you look at tensile, so first we have to decide what is this, right? This is, we have to decide which one, hoop or axial. It's axial because I explained it over here. And this is stress, right? The stress is the unit of applied load divided by A, right? So which is this is area, which is length squared, right? And this is length. Sorry, this is length, and divided by cancel. This would be force per length, right? Which is force per inch length. So you times this, which is inch, and this is going to give you, I think, 440, 540. Yeah. So pounds per inch, and that is pretty straightforward. You sort of just have to see it. While you see this. And the next thing, also remember that the thickness, right? It's this over here, right? This is the thickness, and the upper and the lower is going to hit that little angle over here, little area over here. But we're not doing the area, we're only doing the length, right? Which is that. That's why if we're going to use the diameter, then it's per length around the thing. We have to use the thickness, right, to calculate the force per inch of the weld between the upper and lower section, right? Okay, and it goes up to C. Determine the absolute maximum shear stress in the cylindrical portion of the tank. Usually, maximum shear stress is the maximum tensile stress minus subtract the minimum, right? Which is 8,640 psi. I mean, sorry, what? Yeah, psi. This is the maximum, right? This is the maximum that we calculated is the hoop stress. Now, the next thing is that there's three form of stress. So this is H, and then there's the axial one. This is the second one, and there's a third one. The third one happens is the reaction from inside of the tank and the atmospheric one, right? And so atmospheric, I think, is like 13.4, right, psi, and the inside of the tank is only 180. And these two, like, you add them together, it's not even like 10% of the maximum, right? It's not even 10%. So we just tend to ignore it because it's extremely insignificant that we almost treat the third stress is caused by these two these two force. In this case, pressure time, is per area, which is a form of stress, right? These are so insignificant compared to this one over here, so we just say, so this is 8,640, 4,320, and 3 is 0, and this is the minimum, right? So minus 0 divided by 2, and in that case, this is 4,320 psi, and this is tau max. Tau absolute max. Okay. Perfect. All right. So yeah, usually you can treat it like that, or you can just also determine the fact that, well, let's draw this on a Mohr circle, right? So after this point, you can just pause the video. That's probably what your professor requires you to do, but my professor requires us to draw Mohr circles in almost every single, I guess, question that we do as much as possible. So I'm gonna share the idea of how to draw this Mohr circle, right? So this is a different color. So let's say this is AQ, right? And this is 0, P3, right? Which is, and this is, sorry, stress 1, stress 3, and then stress 2 just happened to be right in the middle, right? At 2, which is the axial's A, and then we draw more circle out of this, right? Is absolutely terrible circle. Okay, this now looks a little better. So what did we find? We'll find H2, HA and 3, yeah, 3. And you can find the maximum absolute like shear stress because this is shear, right? And this is stress. So this is still the distance from, H minus A, which is also 4,320 psi. This is like just because this is the maximum shear stress we can get on this circle, right? When we translate the system into a Mohr circle system. So this is one other way to check that you're correct, and my professor just asked us to draw the Mohr circle when we're doing this kind of problem. So I usually just draw it out and present it the idea, and also helps you to check your questions that oh, I got it correct, right? Okay, so this is all that you needed for this question. It's super easy. It was only the second question of the chapter. The later ones gets a little tough, but it's still these two main equations, right? These two, and you sort of just apply your other engineering knowledge from this class and add on top of it, which is probably torsion and probably some Mohr circle stuff adds on top of it, or some chapter 2 or 3 basic stuff, right? Shear stress, shear strain, stress, all that stuff. Okay, hopefully this was helpful. Good luck on your studies, and I'll see you in my future videos. Bye.